question is if a lens is placed in water, how will its focal length change? And focal length change, how does the focal length change? Consider a convex lens of focal length f. So f is the focal length in air. Now you are placing it in water. What will be the focal length? Will it be more than focal length in air, or will it be less than the focal length in air? See, normally glass is having a refractive index equal to 1.5, and refractive index of air is taken as 1, and refractive index of water is taken as 1.33. Now when you place the glass, a lens made up of glass in water, then the formula which is used, which you will learn in 12th standard, it is 1 by f equals lens maker's formula, n2 minus n1 by n1 into 1 by r1 minus 1 by r2. So I will just tell you what it is. See, n2 is the refractive index of the material, that is, in this case it is glass, that is 1.5, and n1 is what is outside, the mediums, so n1 is air in this case, so it is 1, and when you place it in water, then n1 becomes that for water, then it becomes 1.3 when it is placed in water. Now if I use that formula here, I can have 1 by focal length in air is equal to 1.5 minus 1 by 1.5, I mean 1 by 1 multiplied by, see, the other terms remain constant, that is a radius of curvature. So let me write it by k. Then f in water will be equal to 1.5 minus 1.33 by 1.33 as per the formula into k. So when you substitute, and you will find this will be equal to 1 by f in air will be equal to 1.5 times k, and 1 by f in water will be equal to some 0.127 times k. So when you find the ratio between f in air will be equal to f in air by f in water will be equal to this 1 by 1.5 divided by 1 by 0.127. So if you simply divide, you will have 1 by f in air divided by 1 by f in water equals 1.5 by 0.127. Now this will go to the denominator, this will go as the numerator, so f in water by f in air will be equal to 1.5 by 0.127. So f in water will be equal to 1.5 by 0.127 times f in air, or in other words, you are getting a number which is greater than 1 here. So the focal length in water is more than that in air. So you need not have to go all these things. You have to say if the convex lens is placed in water, its focal length will increase. Reason behind is like this, and you will learn in the 12th standard. Then which lens, thick or thin, has the greater focal length? So who is having greater focal length? See, when you take up a thinner lens is having a greater focal length. Thinner one is having greater focal length compared to thicker one. So thicker one means smaller focal length. And the same question can be asked for power, because focal length is inversely related to power. So power is equal to 1 by f. So the one who is having greater focal length, that is thinner lens, will be having lesser power. So thick lens means great power, larger power, and focal length is less. Thin lens means focal length is more, but the power is less. I am saying in terms of the convex lens. Now next question is what characteristics should a fuse wire have? So fuse wire, obviously it should have a low melting point, and it should have a considerable resistance so that it gets heated up, because H is equal to heat generated is equal to I squared RT. So current flowing, and R also more means heat generated will be more. and it should be also ductile. Next question is 30 bulbs are connected in series. So you have 30 bulbs connected back to back. So 30 bulbs are connected in series. If one bulb fuses, so one of the bulb fuses, and the rest 29 are again connected in series. The question is, will the light or the brightness of the light increases or decreases? What will happen to the brightness? Will it increase or decrease? See, when you are connecting the bulbs in series, the resistance get added up. Resistance is more for 30 bulbs compared to resistance for 29 bulbs. Now power is equal to, same potential is applied. So power is equal to V into I, or you can write it as V into I. You can write as per Ohm's law, V by I is R. So you can write I equals to V by R. So when you substitute it here, you will have P is equal to V squared by R. So potential applied being the same for whether 29 or 30 bulbs. So power of 30 is equal to V squared by resistance of 30, and power for 29 is equal to V squared by resistance of 29. So resistance of 29 is less compared to resistance of that 30. So obviously power for 29 is more than power for 30. So brightness is more for the same 29 bulbs connected in series compared to the 30 bulbs connected in series, because the resistance decreases, so the power increases. So why I have taken this relation is because the potential is applied, potential applied remains the same for whether it is 30 set of bulbs or 29 set of bulbs. Next question is why tungsten filament is used in bulb and why the bulb is filled with inert gas. Now, why do you use the tungsten filament in bulb and why you are filling an inert gas into it? See, tungsten filaments, bulb's intention is to, so actually the filaments get heated up. So when it gets heated up, then it gives out light along with the heat. So it should have a high melting point. So high melting point should be there. So that is why you are using tungsten near to some 4%. Then why inert gas is filled? See, as the temperature increases, the tungsten filament may get oxidized or sometimes it will burn. So in order to avoid this oxidation, you are filling with inert gas. Inert gas like argon is filled so to avoid oxidation or burning off. Next question is why thick wires are used in the leads of an electric radiator. Why do you use thick wires for those electrical instrument appliances which use high amount of current? See, so those devices are of higher wattage, means it is having more power, it consumes more power. So as we did in this earlier problem, so power is equal to V squared by R, and if R is less, the power value is more. So more power means you should have some low value for resistance. How can you reduce the resistance? Even though we are talking about the instrument, so you have to transfer more power to the instrument. So the one who is carrying the power or one who is passing this electricity must also have a lower resistance. So how to reduce the resistance? You increase the surface area. So when area increased, resistance decreases. When length is increased, resistance will increase. So when you increase the area, so if you make a thicker wire, the area increases, the resistance decreases, so you can transfer more power. Now next question is which color has the higher critical angle? See, critical angle is related to this total internal reflection. That is when a ray from a denser medium moves to a lighter medium, and that is also obliquely at an angle to the surface. At a particular angle of incidence, IC, let it be critical angle, then the refracted ray, which should have moved to the second medium, grazes the surface or passes through the surface, and that particular angle you call as a critical angle. Now in that case, the angle of refraction is equal to 90 degree. So when you use this sin I, Snell's law, sin I by sin R, now here sin I is the critical angle and sin R is the 90 degree. So sin I critical by sin 90 is equal to refractive index of the second medium with respect to the refractive index of the first medium. Here refractive index of the second medium, see the second medium is where the light tries to go, so it is air. So for refractive index for air is equal to 1, and this is, let it be water, let me write it as NW. So I can write it as second medium by first medium, so N in air by N in water. So in that case, this will be equal to 1 by N in water. So I can write sine of the critical angle is equal to 1 by the refractive index of the medium through which the light is actually passing now. Now this refractive index, if you take water or glass, the refractive index is more for violet compared to that for red. So violet is having more refractive index and this is having less refractive index. So refractive index more means the denominator is more. So denominator more means 1 by denominator will be a smaller quantity. So sin IC will be a smaller value for red, for violet, and sin IC will be a larger value for red. And you know sin's value increases from 0 to 90. So sin IC smaller value for violet means IC or the critical angle is small, because sin 30 is 1 by 2, sin 45 is 1 by root 2. So the value is actually increasing from 0 to 1. So smaller value for violet means this IC value or the critical angle is smaller for the violet compared to that for the red. So who is having the smallest critical angle? That is violet is having a smaller value for the critical angle, that is the angle of incidence that with the ray grazes the surface compared to that for the red. Hope you understood this one. Next one is two objects of mass 10 kilogram and 40 kilogram possess equal kinetic energy. So 10 kilogram and 40 kilogram are possessing same kinetic energy. What is the ratio of momenta? So what is the ratio of their momenta or momentum? So singular and plural, momentum and momenta. Same kinetic energy. So how is this kinetic energy and momentum related? See, as we know, momentum is equal to mass times velocity. So if I make the square of this, p squared will be equal to m squared v squared, and I know kinetic energy is half mv squared, so I will try to make this right hand side like that. So p squared by m will be equal to mv squared, multiply both sides with 1 by 2, 1 by 2 p squared by m is equal to half mv squared. So kinetic energy is equal to p squared by 2m. So this is the relation. Now you have two bodies of mass 10 kilogram and 40 kilograms. 10 kilogram and 40 kilogram. So if I write their kinetic energies, kinetic energy for the first body is the momentum of the first body by 2 times mass of the first body square. Similarly, kinetic energy of the second body is equal to P2 squared by 2m2. Now if they have said this left hand side is same for both, the kinetic energy is same, so I can substitute it like P1 squared by 2m1 is equal to P2 squared by 2m2. So let me cancel this 2, then I can have P1 squared by P2 squared is equal to m1 by m2. Now they have asked the ratio. This m1 is 10, m2 is 40. So p1 squared by p2 squared is equal to 1 by 4. So p1 by p2 is equal to root of it, so I can write it as 1 by 2. Or you can write p2 is equal to 2 times of p1. So this is that. What is the question? Is what is the ratio of their moment? Is p1 by p2 is equal to 1 by 2. Then name the radiation emitter. Next question is name the radiation emitted from a radioactive source which has lowest ionization power and most penetrating power. See, the penetrating power depends upon how much energy it possesses. So three types of radiations are emitted: alpha and beta and gamma. So the gamma is the highest energy. So highest energy, and it is also an electromagnetic radiation, and it is not charged. And beta is negatively charged, and alpha is similar. Beta is similar to electron, and alpha is similar to helium nuclei, and it is positively charged. So who is having the highest penetrating power? Gamma, because it is having the highest energy, it is having the highest penetrating power. Now who is having the highest ionization? The one who is having greater mass ionizes more, so the alpha is having the highest ionization power. So hope you understood these 15 questions. Thank you.